Alright, let's see what a fast scan would look like of this. So we've got our fast, it's actually a Sonotest Q-Scan 1 probe, but it's a fast type probe, an angled all-way probe for thin-walled material. So let's recall that cal. So that's what I have in here as my fast JE probe. Open, open, open. Contents recall. And we recall the cal, let's check the cal. Go to the four side holes. I'm just going to put the index point of the transducer right on the notched mark on the block for 70. 1 is near 1, 2 is near 2, 3 is near 3, 4 is near 4, and our material thickness is 368, so I'm going to use the 400 hole to set the gain. Aim at the 400 hole, and we'll increase the gain. It's still a little high in the gain. Let's try 51 dB even. That gets us close to 50%. So I'm going to set my reference dB there. We're going to do a couple of scans. We're going to do a butt-up scan from each side and a setback scan. And the setback scan is going to be alright, so our setback scan will have our index point, the thickness times 2.75. That'll give us our setback distance. So 0.368 times 2.75 equals 1.012. I'm going to call that 1 inch even. So we're going to have our index point 1 inch back from the center line. And let's just go ahead and do a quick estimate of where that is. So that's going to be back around here. And we'll do a scan from each side like that with our fast probe. And here we go. Didn't see much there. Let's try that butt up, right up close to the weld. Again, didn't see much there. The whole thing looked pretty consistent. It didn't look different in any one spot than the other. Let's try this butt-up scan here. Here we go. Whoa, yeah, that's very different. And that's giving me a good clue what it is already. It's very close to the left-hand edge of the screen, as a toe crack would be. That's got quite a bit of amplitude. Let's, just for information, let's try the setback scan. And yeah, right in here it looks different, right in there, that area. But right here at the fast, this gave us a quick tip-off right away. This signal out here, that's looking like something near the OD. As close as we can get to it, jammed right up to the weld toe. Alright, so that looks like an OD weld toe crack right there. Let's, if it is an OD toe crack, we should be able to bounce into that at the end of the second leg with a 45. Alright, let's find this flaw with the 45. And there it is. It's an OD flaw. I'm going to cheat a little bit. I'm going to look at an ID corner on the edge of the block. I could pull back to find the OD corner trap signal. And that's going to be pretty similar location to what we see here. Starts about 3/8 from the edge of the block and ends about 1.25 inches from the end of the block. And for surface distance, we've got a surface distance minus X value of just about 1/2 inch. And that puts us right at the toe of the weld. Alright, so we're going to go ahead and do some flaw height sizing. Alright, so let's use our 45 to do tip sizing if we can, to get a flaw height on this toe crack. And I'm going to try to measure the full V to the corner trap signal, and then get a separate reading to the depth of the tip. And if I subtract that depth from the full V depth, that should give me the flaw height. So let's try and do that. So we'll start with finding that there's that OD corner trap signal. And let's get back to reference. All right, I'm going to say that's at 714. So the OD corner trap signal is at 714. Going to make a note of that. And now let's see if we can go in there and find a tip signal on that. Okay, there's our corner. Let's push in and look for the tip. And I think that's the tip that I want right there. I'm going to call it right there. So I'm going to say 614. Let's make a note of that. 614. Okay, 714 minus 614 is 100. That's a nice, easy coincidence. And let's plot that size onto our sketch. 100 thousandths flaw height. Something like that right there. Alright, so there's our weld toe crack. Alright, thanks a lot. Bye for now.